In the cold winter, the owner of a 2018 Geely DHowever 50 reacted that when the ignition switch was turned on, the instrument ready light was on, the no system fault light was on, and it was found that the power battery thermal management system PTC heated water pump did not work. As a maintenance technician, how should you start to deal with this kind of fault when you encounter it? 1. We have 2 learning objectives for this course, which are 1. Knowledge of the components and working principles of water pumps. 2. Master the components and working principle of cooling fan. 2. We will learn today's content in the following 2 parts. Part 1. Composition and working principle of water pump. 1. Components of a water pump. The water pump of the thermal management system of the power battery is composed of a cooling pump, a turbine, a motor and a casing. The water pump is the power element for coolant circulation as shown in Fig. 1. 2. The role of the water pump is to pump the coolant in the high-pressure battery pack, pressurize the coolant in the cooling system, prompt the coolant to circulate in the cooling system, take away the heat emitted by the power battery system, and cool down the power battery. 3. How water pumps work. Power battery compensation kettle, radiator, water pump are filled with coolant. The impeller is driven to rotate the shell. The coolant is driven by the impeller to rotate together. Under the action of centrifugal force, the coolant is thrown to the edge of the impeller and thrown out of the drain into the power pack inlet pipe. At the same time, the center of the impeller generates a vacuum. The coolant is sucked into the pump casing from the pump entry port. The impeller keeps rotating, and the coolant is continuously circulated. When the pump does not rotate, the power battery thermal management system or the drive motor and the control system will have overheating faults, and the vehicle will be limited to power driving or shutdown, as shown in Figure 2. 4. Cooling water pumps are divided into 3 categories: closed, semi-closed, and fully open pumps, whose internal disassembly structure is shown in Figure 3. Part 2. Overview of cooling fans. 1. Cooling fan on condition. The cooling fan is controlled by the vehicle controller VQ. When the coolant temperature is greater than 45 degrees centigrade, the VQ receives a temperature signal, at which time the cooling fan starts to work. The VQ controls the pulse width modulation PWM module to make the cooling fan work at a speed of 8 gears within a duty cycle range of 20% to 90%. The cooling fan on condition depends on 2 important factors: the electric air conditioning compressor EAC and the motor controller MCU coolant temperature. The cooling fan starts when the electric air conditioning compressor EAC is switched on or when the coolant temperature at the motor controller MCU is greater than 45 degrees centigrade. The cooling fan is not activated when the EAC compressor is switched on. 2. Cooling fan stop working condition. Coolant temperature of motor controller MCU is lower than 65 degrees centigrade, measured 47 degrees centigrade, and electric air conditioning compressor EAC is off when the ignition switch is off and the electric air conditioning compressor EAC is off. If the coolant temperature of the motor controller MCU is higher than 65 degrees centigrade, the cooling fan continues to work 30-second when the ambient temperature is lower than 10 degrees centigrade, 60-second when the ambient temperature is higher than 10 degrees centigrade. 3. Cooling fans are classified by control. According to the different control methods, the drive motor electronic cooling fan of pure electric vehicles is divided into intelligent temperature-controlled fan and non-temperature-controlled fan. Non-temperature controlled fans work when they are energized and have a fixed rotational speed. Pure electric vehicle drive motor cooling fan selection should also pay attention to the fan's diameter, speed, the temperature resistance, protection level, air exchange mode and other parameters. 1. Smart temperature fan definition, with the electronic control technology of microcontroller as the core. It can accept and convert PWM signals and can realize CAN bus control. 2. Smart temperature fan feature. Some intelligent temperature control fans require external VQ controllers, and the control strategy program of the fan is written on its microcontroller, which corresponds to the VQ and the fan, and cannot be commonly used with other brands of fans in the market. 3. Some smart temperature-controlled fans have the control program written on the fan motor, eliminating the need for an VQ controller for versatility. In this course, we will learn the theory of pump fault diagnosis and maintenance of power battery thermal management from the previous two aspects. I believe you have a good understanding of the whole knowledge point. In the next class, we will learn the operation of pump fault diagnosis and maintenance of power battery thermal management in detail. Thank you very much.